Okay, so let's do a little bit of freezing point depression and boiling point elevation. Both of these work the same way. We have a constant that you have to be given or asked to determine that constant for each of these. The F stands for freezing, B stands for boiling. And so if we're doing, sorry about that. Okay, so I can either have the temperature at which something freezes at be lowered or have the temperature at which something boils raised by adding something to it. And when I add something to it, I need to realize whether it's how many ions is it making. And that's what the I is in this equation. So if I have something like CaCl2, I would equal 3 because that makes 2 chlorine ions plus 1 calcium ion. If I have something like C 6H12O11, I is going to equal 1 because hydrocarbons do not break apart. Their I is always 1. So anything that's ionic, you count up how many particles it makes. Anything that's molecular or covalent, I is going to equal 1. So let's look at a problem from one of the worksheets, 8.8, and I'm going to work out question 9. So question 9 on worksheet 8.8 says, what is a boiling point elevation? So I want to know what is the new temperature at which something's going to boil at for an aqueous solution. So I know my solvent is H2O, and so that tells me that Kb is going to be 0.51 degrees Celsius per molal for a 50 gram solution of NaCl. And so I know right now that I is going to equal 2 because 1 sodium, 1 chlorine. And it's going to be put into 475 milliliters of H2O. So that means I have to use these two pieces of data to determine what my molality is. So I'm going to take my 50 grams NaCl, and it's 58.44 grams of NaCl for 1 mole. And then I'm just going to slide this over because I know I have to divide that number by my kilograms, which is going to be 0.475 kilograms. Because again, 1 milliliter equals 1 gram, and I divide that by 1,000. So on my calculator, it's going to be 50 divided by 58.44 divided by 0.475 equals, my molality is 1.80 molal. Now I'm going to keep that number in the calculator and use that for the next part, which I'm going to say is delta T is going to equal, for boiling, is going to equal Kb, which is 0.51 degrees Celsius per molal, times 1.80 molal, and it forms 2 ions. And so my change in temperature is going to be 0.51 times my last answer times 2. And so I get 1.837 degrees Celsius. The normal boiling point of water is 100 degrees Celsius plus 1.837 is going to equal 101.87. And I have 2 significant digits, so it's going to be 1.18 degrees Celsius is my new boiling temperature, or my new boiling point. Hopefully that helps. Let me know if you have any questions. See you later.